Now it is time to import my parts into assembly design environment. Let's go to start menu, mechanical design, assembly design. Select product 1, go to insert menu, select the existing component, and selecting all components and open, imports my component inside, okay? Now I want to go to edit, move, manipulate, move this a little to right, and select Z to move it up, and move this part 2 up like this, clicking on OK, and before doing anything, I want to show you something. You know that helix height is 100 millimeter, and you know that I used that helix and I added a circle that has about 2 millimeters of radius to create this spring. Now you can see that it adds another 2 millimeters to the height of the helix to get to height of this spring. At bottom, another 2 millimeters in top part. So I have actually 104 millimeters for the height of this spring. And the other important thing to mention is this. I open helix 1. You can see that in helix, under part body, I have sketch 1 visible. And this is very crucial because I want to select this vertical axis or the origin, both are okay for coincidence, and I want to have this point for an offset because this is hard to grab the axis of this helix. I want to use this sketch, and if it is not visible for you, you can make it visible by right clicking and selecting hide show again. Okay, now let's go and do the job. The first thing is this. I go and select insert, select coincidence, and if it is not visible for you, you can double click on product. You can see that this activates the constraints here. Selecting coincidence, selecting this vertical axis of this sketch, and you can see that the point is selected. It is not okay. Let's double click on press escape 2 times to exit this tool, and again select coincidence. Now I can grab this vertical axis, and now I can grab this axis of this hole. I have this coincidence here. Now I select the offset, and as I told you, this point is about 2 millimeters above the face of this helix, the bottom face of this helix. So I select this point and click on this bottom face and make sure that there is a 2 millimeters offset here. So I click on OK. Now by pressing Ctrl U, the spring is in its actual place. Now there is a problem here. You can see that the helix should be about 48 millimeters in radius, and it is 28. I can correct it. I can go to part body of helix, select sketch 1, double click on sketch 1. You can see that it takes my part into part design environment, and here I have this offset. I double click on that and make sure that this is 48 millimeters. I click on OK. I exit my workbench, and the helix is recalculated again, and I need to take them back into assembly design environment because now it is in part design environment. Now I have back. Now of course you could go to constraints of sketch 1, and this is the offset that is here. I could double click on that. You can see that again it would take me to the correct place. Let's back, go to mechanical design, assembly design environment, and go to the next part. Now I do not have any plane on top of this spring, so this is very hard to put this spring into a contact with this top part. And actually I don't want to do this because I want to have this spring change height according to the offset of these 2 parts. Now let's do this. First thing, I want to go and select the coincidence. You can see that this is inactivated, so I double click on product 1, go and select coincidence from here. Again, this vertical axis of helix is selected, and the axis of this pocket. Now I have a coincidence. Now the next thing that I want to do is this. Let's press Ctrl U for the time. Let's open calculator. I have 104 millimeters for the a spring's height, and that is because 100 millimeters is for the helix height and 2 millimeters in bottom, 2 millimeters in top, and I have added them to have this 104 millimeters. 30 millimeter is gone inside the pocket of the bottom part, and 30 millimeter should go inside this pocket, and it makes me 44. So I will have an offset of 44 millimeters between this face and this face. So I type in 44 and click on OK. Pressing Ctrl U, everything is in place. Okay? Now I want to start another thing. I want to make sure that if this offset is bigger or smaller, this spring will change according to this offset. That means I need a formula. So let's go to Tools, click on Formula, and the first thing that I want to have is this. I want the helix's height change according to this offset. Okay? I know that the helix's height is 100 millimeters. So let's go and find the helix's height. So if I am in helix, you can see that helix has a height here, and that is 100 millimeters. I go to add a formula here. Now I have a formula for helix's height. And if helix's height is the offset between these two, so I go to constraint and select the offset that I have just added here. That's 44 millimeter. You can see the value here. Plus, I have the pocket's depth here. So I go and select part 1, pocket, first limit depth, because I only have it in one direction. That is about 30 millimeter. You can see the value here. Plus part 2's, I open part 2 here, and I deactivated it. And select pocket here and select first limit depth. Now I have all this, and the helix height is like this, and I should subtract 4 millimeters. So I type in 4 here, and it should have a unit because all of these are in millimeters and the 4 does not have a unit. So I find units here and double click on millimeters, and now it has a unit. So I click on OK. You can see the helix height is 100 millimeters, and it is based on the formula. So I click on OK. If I open helix, and this is the helix, this is helix 1. Let's close this. You can see that the formula is shown here, and it tells me that there is 100 millimeters of helix height here. Now this formula is created for me. I want to show you if I select the offset that is 44 millimeter here and change it to, for example, say 100 millimeter. There is an update needed here, and this tells me that helix needs that update because this is getting red. So I press on Ctrl U. Now you can see that after the update, the helix height is 156 millimeter, and the pitch is of course not changing here. It doesn't matter. And I should make sure that the pitch is changing according to this height, because I'm not going to have revolutions change. And actually it is changing in revolution. Okay, let's make the offset about 200 millimeters and see the update. You can see that the height is going to be 256 millimeters, and make sure that the update is going to be reflected here. Now you can see that it has revolutions and still pitch is not changing. So let's go to helix definition. I double click on helix definition here and go to properties. No, I'm not going to properties here. Actually, I want to go to helix feature. So I double click on that and the helix feature is there. Now I can see that revolution is not changing here. I need to have revolutions, so I cancel this out and change the offset to 44 again. I need to double click on offset and make it 44 again. So press Ctrl U and everything is back to its original place. I go to tools and select formulas. Here I want to have a new parameter, and this parameter is going to be of type real or integer. Doesn't matter which one you select, because here I want to have a number with no fractions. So I select real. Real is okay. And the name of this parameter is gonna be revolutions. And I press new parameters of type. You can see that this is here. And I make sure that I have about, for example, 14, 15 or anything that I want to have. For example, 14 revolutions or 10 revolutions is okay. And rename it. I want to rename it to revolutions again because it didn't change the name, revolutions. And press apply. You can see that revolutions is 10, okay? Now I want to make sure that the revolution is not going to change, and this is the parameter that I just created here. And I want to make sure that pitch is changing according to revolutions and height. Because revolution is not going to change, pitch should change. So I right click on pitch and go to change the formula by clicking edit formula. And I know that the pitch is height, and I select height divided by the number of revolutions. So I find the revolutions here, and if I cannot find it, I can go and find it from the relations or parameters that are added here. I cannot see this here. I just type in the name of that parameter and click on OK. Now you can see that it tells me the pitch is 10 millimeter. You can see that it should be updated because I have a parameter and I am calculating the pitch based on the parameters. So I press Ctrl U. You can see that it changes according to this. Now if I double click on offset and make sure that instead of 44 I have 70 millimeters offset, and I click on OK and press Ctrl U, you can see that the helix is wider. And you can see the pitch is 12.6 millimeter. And again, I change it to 100 millimeters of the distance, press Ctrl U. Now you can see that again the helix is wider because the pitch is 15 millimeter. And again, I do not have any more revolutions here. One more check. I want it to be 200 millimeters, and this is very extreme. And you can see that this is very nicely showing everything. Now the pitch is 25 millimeter. Revolutions, of course, is not changing here. So this is the formula that I use to show you how you can assemble items based on them, how you can create some parameters. And again, let's go to Tools menu. I want to show you something, and this is not reflecting here. If I go to Tools, Options, Open Infrastructure, and under Infrastructure, go to Power Infrastructure, I have relations, parameters, and everything ticked. And this means that you should see everything in this specification tree. And I guess this is a bug that I do not see it here because I should see it here. Okay, that's it. And next section I want to show you more on assembly and other topics.